Suppose you have a time series and you use the time series to predict some kind of trend, and based on the trend, you want to figure out when is the first time the time series will hit a certain value. So for example, here, given this time series, you may want to figure out at what time the value is equal to something like 30. So if you are using something simple like linear regression to figure out the linear trend, then you can get the equation of the trend line. And given the value y, say is equal to 30, you can solve for the value of x, and that x is the time the value hits 30. However, if the trend is nonlinear, then it may be difficult to solve for x given a value of y, or maybe if you are using like the forecast function in Excel, which does exponential smoothing, then you are not given the equation of the line, so you can also not directly solve the equation and figure out the value of x. So in those cases, you should use solver, but before that, let's first compute the trend. So let's add a few time points and compute the trend using the forecast function, and the target value is this and the values are these. Let's fix the reference and the time. Let's also fix the reference, and let's not worry about the seasonality and other stuff. So now you get a prediction, and you can see if the target is something like 30, then it should be somewhere between 126 and 133. So it's not clear what exact number it is. You can do some kind of linear interpolation, but well, maybe you don't want to do it manually as well. Maybe that's because the trend may not be linear, so you may not want to do linear interpolation. But in any case, let's plot this and see if it's actually a line. So let's see this. Okay, so it looks like a line, and let's extend this backwards. It is a line, and let's say estimate. Okay, so the goal is basically find where this point is such that the value of this trend line is 30. We want to find x value at what time this happens. So the simplest thing to do is let's create a few more points, and let's create a space in between. So the simplest thing to do is just to try different numbers, right? So we notice between like 120 something, so let's say 129. So it's kind of close. If we do 130, it's maybe a bit worse. But in any case, we can just try different numbers here, and that sometimes it may take a long time to do that. So we may not really want to do that manually. So instead of doing things manually, solver basically does exactly what we did. Not really exactly, something similar, by just try to change the numbers here and see how this thing changes, and then figure out like exactly what this number should be such that the number here, this number, is exactly 30. So let's do that. So let's first go to Data tab, and there should be Solver. Again, if it's not there, just go to File and More and Options, Addings, and then here, Go. Make sure that this Solver adding is checked. Then you will see the Solver thing here. So click on Solver, and let's get rid of what we did the previous time. So the objective. Okay, so the objective is making this cell exactly equal to 30. So value of means we want this objective to be equal to 30. And the way we do that is by changing the value here. So again, we're just changing this time such that the value of this objective is equal to exactly 30. and we don't have any constraints, so it doesn't matter whether we want them to be non-negative. And if we know the optimization is linear, we can use simplex. If not, then just the safer thing to do is always use nonlinear optimization. And that's all, and let's just click solve. Okay, so click OK, and it will show you the exact number. So we set it somewhere between 129 and 130. That's the exact number, 129.257 or something. Well, we don't really need that accurate, but yeah, suppose we want some level of accuracy, then doing this is better than just manually try different things. Okay, so that's one way. And the problem with this is, suppose the trend is nonlinear, or, for example, there's seasonality. So it will be something like a sine curve around this line. Then there may be multiple points where we hit the target 30. And if we just do this, then it's not clear what this point is. Like, is this the first time it hits 30? We don't know. So maybe we should do something different. And the way to do that is, now let's make the objective the time. And instead of setting the time to a certain value, we want to minimize the time by changing the time. So of course, if we do that, just then the time will be negative infinity, so it doesn't help anything. So we want some kind of constraint, and the constraint we want is, we want this value to be larger than or equal to 30. We can make 30 reference to some other cell, or I can just type 30 here. So now let's say that's okay, and then we get our constraint here. So what this says is, we're minimizing time subject to the constraint that the value of the time series is above 30. So in English, it says we want to find the earliest time when this thing hits 30. Okay, so that's optimization. Again, we don't know if it's linear, and it doesn't matter whether the variables are non-negative, and especially here, it must be larger than 30, so it must be positive. So it doesn't matter whether we check this. We can solve, and then okay, then, well, it solves to exactly the same thing, so we're okay. All right, so another thing that we may want to do is, we may want to be either pessimistic or optimistic. So in that case, instead of using the estimate, we may want to use the estimate, say, plus, then we're kind of optimistic, plus the confidence interval. So estimate confidence interval, target date is this, and the values are these, and the time is this. And suppose we only want to be 90% confident. If we don't have it, then it's 95%. But in any case, is there anything wrong? Okay, I think it's okay. So let's check. And suppose now we want to make this number 30 instead of this. Then you can probably guess the way we do it is exactly the same. Right? So we want to minimize this by changing this. And instead of constraint of this estimate to be larger than 30, we want to change it. Maybe we can just add another one, but here I'll just change it. I'll change it to this. Okay. Get it back here, and it doesn't matter whether it's non-negative. So click solve. Okay, so now you are making this number, it's kind of slightly more than 30, but that's kind of the more optimistic version. So you are 90% confident that, like, the earliest date is, say, a time that's 103 days after the initial date. By the way, if you know the initial date, say it's equal to February 2nd, and when is this happening? So we can just do this plus, actually, do the time plus this. So kind of the earliest date it will hit 30 is like in May, and kind of on average is this plus this, which is in June. And of course, you can do the other one similarly if you have the other pessimistic estimate. So instead of plus, you can just make it minus and run solver again.